We're gonna spend a minute, we're gonna demystify what's going on here. I don't want it to be intimidating. You can do this, you can do this. This video is about how to install these lights anywhere in your home. In this case, we're pulling down the fluorescents that are existing, getting rid of the toxins and nuisance flickering, and we're installing aesthetic LEDs in a master walk-in closet. Here we go. Grab the lens on the fluorescent fixture, pull it out. It's going to be brittle. These old fluorescent fixtures are going to be brittle. Might shatter in your hands, but they are just acrylic. All right, it's down. The power's already off. You rotate the bulb 90 degrees. Bring the pins out. This thing, if it shatters, it will explode. You'll have glass and mercury and fine white dust. I don't know what type it is, everywhere. So get it to a safe place. These are toxic. Your city probably has a toxic waste disposal that you can use for free. Pinch the internal cover. There are tabs that hold it in on each end. Down it comes. All right, let's see what we've got. It looks like the fixture is being held up by a toggle bolt on each end. First, we're going to disconnect the wiring. We've got the hot coming in. We've got the neutral. We're in a residence, so we know we have 120-volt wiring. Lefty-loosey takes the wire nut off. I don't reuse wire nuts. I throw them away. If they've been in service, and these are as old as the lights, no doubt, I pitch them. They're gone. Wire nuts are dead to me. All right, disconnect the ground. Straighten it all out so we can peel the fixture off it. Take my linemen's, lefty-loosey. That's 12 gauge. Up here, the grounds are twisted. I'll take it all apart in preparation for sliding this fixture off. There it is. All right. These toggle bolts are kind of a long haul. They're probably 3 or 4 inches long. It's a great time to pull out an impact driver and just zip them out. I'm going to loosen the other one before I get this one, dropping out of the ceiling on me. So I'm putting a little downward pressure on the bolt itself, just a little bit of weight, because I want the toggle on top of the drywall to catch, and I don't want the toggle and screw to turn together. I want them to turn independently, so it actually comes down out of the ceiling here. Since I've got plenty to work with, I can go by hand. I can spin a little faster, freehanding it. There it is. We've just removed 2 fluorescent lights from this ceiling. Those are 4-foot T12 fluorescents. Pretty inefficient at this point, even though they were cutting-edge technology like 40 years ago. And let's talk about placement of these lights in the ceiling. I've got a top shelf that is 16 inches deep off the wall. What I want to consider is the spread of light, because I want light getting into the shelves. I don't want to position the lights such that I'm casting shadows. We're going to have a total of 6 lights in this space. We're going to have a lot of overlapping spread. The lights, and usually in the instructions, they'll be, it'll indicate the spread of the light, but these lights have about a 135-degree overall spread. So that's a cone of light that's going to come down about like this. So what I'm considering is probably about 12 inches out from that top shelf. such that we get a good illumination into every lower shelf, subsequent shelf. And so rather than the 16 of the top shelf, probably be 28 out to the first light, and that will replicate itself around the 3 sides of the closet that have shelving. I think it's important to know what your final product looks like and to make sure that you're illuminating the clothing, the colors. Allow the lady of the house to make a good selection. So this homeowner has communicated that they actually want, because of the width of the hanger and some potential final larger projections of shelving, to come out to 34 inches to center of the first light. So that's what we're gonna do here. All right, no, actually, let's do 34 by 34. Guys, always use pencil, no Sharpie on drywall. It's so hard to cover, kills paint, 3 coats later, ugh, hate it. And always use a folding rule. Always. No, you can use a tape measure. I'm kidding. Love my folding rule. All right, there are my crosshairs. Nice clean crosshairs. So what I'm gonna do before I cut a single hole is I'm gonna identify my locations, because if I need to, based upon framing, shift my pattern or any other type of obstruction, I wanna shift the whole pattern. I don't wanna have one light that's 3 inches out of sequence with the greater picture. So I'm gonna spot my holes, I'm gonna probe and feel and explore to make sure I've got adequate space. Now the beautiful thing about the wafer lights is they're a 1/2 inch deep, 1/2 inch thick. That's the same as drywall. And what that means is I probably won't hit any obstructions that'll prevent me from putting in the wafers, as opposed to a recessed can light or pot light, as they've been called. That would have to be dialed in to fit around every obstruction in the ceiling. So this really is a great application and product. Feels good. Location number 1. I'm just gonna spin that around. Feeling, oh, beautiful, wide open. Let's spot the other 5 before we cut the first. Okay, so we've marked our 34 and 34, and what we wanna do is find the center between the 2. So I'm gonna go from mark to mark, crosshair to crosshair. I've got 51 on the money, so half of that, 25.5, puts me here. This is one place where a folding rule, guys, it's a no-brainer. And then I'm gonna go 34 off the wall to that mark, finalize my crosshairs. If I'm operating in an older home where things are just plumb out of square, I might not be able to measure along the wall. Oh, I got something. I might not be able to measure along the wall because I could have an 1.25 inch, 1.75 inch variation in that wall, and I'm gonna end up with lights that aren't in a straight line. So some kind of straight edge, a laser, anything between the marks to make sure that I'm in line, if there's any question about the integrity of the wall, is a great idea. Boom, right there. All right, so let's move over a bit because I know I'm gonna get coverage. I feel my framing running this way. My eyeballs are on the end of the screwdriver blade. Oh, that's the edge of it. Okay, the other edge. There it is. I think it's gonna work. Again, wafer light, disc light, 1/2 inch thickness, same as drywall. Great. So I went ahead and took a moment to set the laser on the floor, plumbed the first line, shoot across the ceiling, and now we've got certainty that we're dialed in 3 in a straight line. As long as we cut our holes true, it'll be a beautiful outcome. And if you're working for an electrical engineer, they'll notice an 1/8 of an inch. So at this point, we've mapped everything to the ceiling. We have confidence that it's gonna be a good fit. I've got 3 different ways of cutting holes. I'm gonna show you all 3. First is I just cut out a little cardboard template. There is a margin for error, so it's not a perfect circle, but it's gonna be good enough here. And I'm gonna undercut just a little bit because I'm gonna come back with my jab saw. After I'm gonna cut it with the jab saw, then I'm gonna come back and clean it up just a little bit, trial fit that, and just ease that baby in there because I want as much drywall to grab too, so it's not slipping and messy in the hole. So here it goes. Template to the ceiling. Again, a fine pencil line so it's easy to cover with primer or paint. Ooh, we'll keep it tight to my template. There it is. the old-fashioned method. And I'm going to cut with the thickness of my blade on the inside of the line, inside of the template, so I don't accidentally add a 1/16 or an 1/8 of an inch all the way around my template. I do only have about 3/16 to play with, so that would start getting a little sketchy. And plus too, the jab saw is so forgiving. I'm gonna feel what I'm working into, and I'm gonna feel the difference between drywall and something else I could come across, like a wire or a pipe. I don't wanna cut into that. This is probably not the greatest time to be utilizing an aggressive powered tool like a Sawzall. And one more thing. Look at the how the blade is shaped. It's narrow at the top. That's going to give a lot less resistance if I'm using this cutting portion right here to turning and following that circumference of the circle. If I'm full depth, not only do I risk hitting something in the ceiling, but I also, there's more resistance to that turn. I'm going to get a sloppier cut because I'm using a straight blade on a round cut. Bada bing, bada boom. Oh, I like it. I like it. I'm actually not going to snap it up in there just yet. That's a good fit. Beautiful. Wide open. All right, this is a good time to talk about why I selected this product. One, it's incredibly forgiving on the layout because of that disc nature. The only thing that's beyond a 1/2 inch thickness is the wire protrusion itself. You don't want to crank and bend that over and cause damage to the wire. And the spring clips, a little bit beyond 1/2 inch. So that's going to be real forgiving as far as placement. But also check this out. And that under 6 inches right there. Most can lights are going to have a larger profile than that, unless you get a low profile can light, recessed light, pot light, all the same thing. It's not going to fit because I've got an attic space up there with storage. So I'm going to do my wiring from below because there's literally plywood sitting on top of the 2x6s, and so not enough room for a can light unless I buy the more expensive low profile lights, and I'm in it for another $125 on the project. And what? This is a beautiful vintage 1980s worth nothing can light that is low profile that we've pulled out of the project. And obviously this is a new work edition. There's no way this is going in the ceiling now, but the overall concept is it does have the ability to fit, but look at everything you're trying to fit and house. So take a look. If you've got nothing in the ceiling already and you're planning this project, this is probably not what you're looking for. This is called an LED retrofit. It's a retrofit because it fits up inside of a can light. Take a look at that. Much larger profile. This is rated for 5 and 6 inch can lights. That refers to the diameter. It's got a typical LED polarized plug there. Only fits one way, and this is the tail adapter that screws into your standard Edison. So this right here is not meant to be wired independently. You can't just cut things back and wire nut into this. This unit has to be housed inside of a recessed light. And it says here on the box, recessed downlight. This is not an independent product. One thing I do like about the LEDs nowadays is they've got the color temperature adjustment on the backside. This one actually has 5 adjustable settings, which is beautiful. You can take your pick. So just so we're clear, this goes with this. And before I plug it together, screw it in. Now, Everywhere you've got can lights that are existing, I highly recommend that you upgrade to an LED retrofit. It's an incredibly beautiful modern look. All of our builders and remodelers are utilizing this. I'm gonna say 5-6 years ago, these were like 20-30 bucks a piece. At this point, they're down to 5-6 bucks a piece. Really phenomenal deal. Black Friday, you can probably pick them up for $2. So a few more things to consider when purchasing your downlight. This packaging is actually really instructive. Juno is a good brand. We've got 670 nominal lumens of output per downlight. That is approximately equivalent to a 60-watt bulb. 10 lumens per watt is the LED to incandescent equivalent that we're used to. And that's nominal lumens because actually all LED lighting products are going to slowly, almost imperceptibly, quite imperceptibly, degrade over time in their light output. Recommended mounting height is 9 feet. Dimmable. If you want dimming characteristics, I'd actually recommend that in any closet that you've got, especially the master closet, because you're going to walk in here in the early morning and you might not want full bright. Now, one thing to note, you can't just necessarily throw any dimmer on your LED lights or there's going to be incompatibility and it won't perform well. So if you want to dim it, make sure it says dimmable, and then if you want to make sure it dims optimally, then find a dimmer that's been rated to be compatible with this product on your manufacturer's website. If you don't want to go that deep with it, give it a shot. 120 volt rated wet location. Look at that, wet location. This is good for a shower. Don't settle for damp location. A shower is a wet location. Those are two different ratings. And so in this case, we don't need wet location. This is a dry location, but just be mindful of that. 9 watt overall use, IC rated. What is that? That means rated for direct contact with insulation. See, the issue there was some of the old lights, and some of the new lights too, they'll have a heat issue. And if you pack insulation around them and you've using them in an attic application, that insulation will trap the heat. It'll actually shorten the life and put you at risk of fire, potentially. CRI, color rendering index. The higher the number, the better the results. Color rendering index means how true will this light display the colors of the space. In a closet, CRI is going to be relatively important. When you're picking out clothes and matching things up, you want them to look their truest form. So pick a number that's 90 or above, my recommendation. 50,000 hour life. Now here's an interesting thought. A lot of us have been frustrated with the results we've gotten. 50,000 hour life means like 25 to 50 years, depending on the use time of that product. Its averaged use is 3 hours per day is what residential lighting gets utilized. If you haven't experienced that full 50,000 hour life, it may be that it's a result of poor installation, like a heat situation, IC rated kind of thing. It could be that it's dirty grid power coming in where your electronics, and LEDs do have electronics. This part of the junction box is actually rectifying AC to DC power for the LED lights. And it could be that the product has actually been damaged by a dirty grid, or it could be you just bought cheap stuff. Juno's pretty well respected. Here's one more thing I want to illuminate. Energy Star. If you're going after some kind of utility rebate for upgrading the lighting, the product is going to have to be Energy Star rated in order to claim that rebate. So check for that little icon on the box. Dirty grid means you're not getting a pure 60 hertz sine wave, and they're fluctuations. See, every component in your home is designed to operate upon certain specifications. And when the electricity coming in browns out or does different things that cause it to fluctuate outside of those specifications, that's harmful and damaging to electronics. It doesn't usually kill things instantaneously, but it does damage them slowly over time. We'll talk about dirty grid power later. All right, methodology number 2. My jab saw, keyhole saw, drywall saw is going to be difficult to cut out my nice true circle where the framing member and these center 2 lights is going right through because the jab saw is intended to cut through the hole and I can't there. So I'm going to use method number 2, and that is a drywall cutter. It's got a blade on either side. I'm matching the blade to, you see I've flipped my product upside down, put down some cardboard so I don't mar the face. I flip my product upside down and I'm matching it to the hole size I want. One thing to note is the hole overall inevitably is going to be a little bit more sloppy. So match it tight, knowing that you're going to get another 1/16, 1/8 of an inch out of it, all said and done. And start small. You can always expand that a little bit if you need to. So my pilot bit, my cutters are sized. My pilot bit slips in there, locks my cutters in place, their teeth all on the edge. We'll have a link for this product in the description. Now I'm locked in. And what I do here, slip it into the dust cup. So I'm going to catch all that dust. This is really useful if you're operating in a clean space. And that cup is going to spin freely. Jam it up against the ceiling. And then there's a spring action that goes on here. Look at that. Spring action that's going to allow me to plunge into my cut. So chuck it up to my drill. Here we go. Wild man. There it is. Sure you got a good seat. Spins freely. If that dust cup doesn't spin freely, what it's going to do is it's going to score the ceiling in this 12-inch diameter all the way around your cut, and you're going to have this big, nasty circle. Nice and slow. Here it is. Easy does it, Tiger. Easy does it. That's it. That's it. That's it. Option number 3, if you have a lot of holes to cut and you want to accelerate the process, now watch out, this baby's going to throw off a lot of dust, but this is a compass that's been installed on the top of a rotozip. The rotozip is going to actually be what's cutting the hole right there, that bit right here, and this pin is going to go in the center of our hole. It's spaced to 2 1/16, so we're going to get a 4 1/8 inch perfect circle out of the cut. The only thing that I'm fighting here is I was real sloppy with my screwdriver exploring that hole, so this pin's not going to sit real clean in there. So I'm actually potentially going to shove a little bit up in there, like some wood chips, to help grab that pin, and then I'm going to spin it around. Anything to say? I love it. Link in the description. So in this circumstance, this wiring is not going to be conducive to what I've got going on. I'm going to show you how to eliminate this wiring, make it safe, and then also at least 2 different methods of running new wiring through the ceiling. We've got the beautiful dynamic of access on the other side of this wall. I'll show you in a second. But if you don't, and you've got to fish the wiring, that's what we call it, fish the wiring, then my recommendation to you is a couple of things. I've got an extension here. This is a 1/4 inch extension that fits the shank of that bit, hexagonal shape. 1/8 inch hex key to snug that down. And what this is going to give me is extra reach right there. Extra reach. So what I need to do is get through framing. I'm gonna hit the box, go this way. That's an easy fish, no resistance there. But when I've got to go across the framing, that's where I'm gonna encounter challenges. I don't want to drill out the bottom of my joist because that's gonna damage the structural integrity. So in this case, I'm gonna get as high and at as steep angle as I can with a small bit that's size that'll fit my wire. The circuit here is a 20 amp circuit, so I'm using 12 gauge wire. That is a match to, number one, code, and number two, what's existing. All right, this is where the extension comes into play. I want to make sure that that framing doesn't have any mechanicals I'm going to drill into. I'm going to let it grab. I'm going to put two hands on the drill. What I don't want it to do is kick and buck, and that thing can actually snap. And we've had team members with injuries and stitches to the forehead, jaw, nose because of the torque that these power tools can create. Boom. Just create a small opening in my 12-2. I don't rip it too badly because you want it to stay bundled up. I'm going to pull that out and I'm going to untwist it as I pull. It's just going to allow for it to pull through the framing a little bit more neatly and nicely. So untwist, pull that out. So I'm going to send it through that hole I just drilled. There it is. I'm going to fish across. Now, if you've got a blind space, my recommendation to you is to install more can lights rather than fewer. And what that's going to do for you is it's going to give you more relay and access points. There's other wiring up there. It's going to give you more relay access points to get that wiring fished through. Take a look at that. Boom. There it is. We just fished it through. I'm going to give myself a little extra. Little bit extra. My junction box is going to be on this side of the framing divide. I'm going to get a solid 12 to 14 inches. Yeah. There it is. There it is. Okay, so what I've got here is I've got a full joist bay, 16 on center joist bay. I've got one hole I'm going to have on either side. I've already drilled this one. I'm about to drill this one. And I want to line those holes because I'm going to have to fish through a blind space with fish sticks. Link to the fish sticks in the description below. So when I drill this hole, I'm going to try to be low. I'm going to be mindful that my bit doesn't damage the hole on either side because I like it that I've got a good clean hole. I want to be in alignment so I'm not trying to fish at a wonky zigzag angle. Bring that down. There it is. Good clean hole, and now I just need to fish through there. So 12-2 is a conductor, is a cable. So 12-2 is a cable with 3 conductors. Haha, check it out. 1, 2, 3. But the thing is, the grounding conductor isn't counted. Black, white, that's 2 conductors. 12-3 would include a red conductor. What I'm doing here is I'm getting this conductor ready to be fished across the opening. Here are my fish sticks. Hello, hello. Now these are nice and flexible. I put 2 of these together. They thread end to end. No problem, easy peasy. Look at that. Fishing apparatus. You can add hooks and loops to the ends to grab that wire. But at this point, I can see my first hole. There it is. All right, I'm in there. Now I've got to get it out of my second hole. My fish stick. I'm sure I'm too high, So I'm gonna bring it down. I might be able to send it through the hole. Tell me if you see it.
All right.
What are we doing right
there,
now?
see it?
Explain.
Push.
Boom. Boom, boom, boom. All right. So my buddy Chris here has just helped me fish this through. I've got nice flexible fish sticks. Right there it is. He's shown a light. I had good alignment. I had a sense as to how high in that framing member my hole was. And I just put a little pressure on my flexible fish stick to bring down the nose, found the hole, in and out. So I took my wire, I stripped back all the conductors but one. Bend it over on that hook. I'm going to make sure it doesn't fall out of the ceiling. You never want to lose a fish. Never, ever, ever. So frustrating. We got this one in like 30 seconds. We lose it, it'd be minutes, hours, and days before we get it again. It's the curse of the fish. Never lose a fish. So I'm using good quality electrical tape. I'm going to tape it up so I close that opportunity to lose it. I've got a single number 12 copper conductor that's holding it on there. I've got a real easy path and I'm just going to ease it through. I'm not going to pull too hard. I don't want to destroy my fish sticks. Ooh, it's going to want to bind and hang up at the holes. Oh, there it is. Come on. Ease it back a little bit. Ease it forward. Let's find that hole. There it is. There it is. Nice and easy. Pull that 12-2 Romex, also known as NM cable, right through there. All right. It's at the second hole. There it comes. Boom. Wiring and cable should never be damaged when it's fished or pulled through raceways or bored holes in framing. So you just got to ease it through there. You don't want to scar up that outer jacket, and it's pretty lightweight. That can easily be done. I'm going to give myself that 12 to 14 inches again. Boom. Here we go. Don't drop your wire each time. Just pull more out. Hook it on the ladder. Save yourself a trip down and up. Now I'm going parallel to framing, nice and easy. Nice and easy. There it is. Boom. There it is. I'm going to plan my wiring routes so that I do not have 3 wires in one junction box. That's going to overload these junction boxes. You want to read the instructions, check your J box, and make sure that you're only putting the number of conductors that are allowed in the box. So this already has 2. I'm not going to add a 3. I'm going to go around the horn. Keep it simple. I'm going to staple on these wires. It's holding it in place. No, there it is. Got it. Well, that's free and clear. Get this old stuff out of here. Again, make sure it's dead. Utilizing, at the very least, a non-contact voltage detector. We're gonna do the same thing again. I'm gonna strip back that 1.5 inches, peel it over. I'm gonna take a little chance. I'll wiggle this wire. I know these lights are tied together, and that one over there is dancing and jumping. So what I'm gonna do is, I'm gonna hook ground to ground. Whoops. I'm gonna cut these down here. I want everything to be as tight as possible, real slim. I don't want a big bundle of tape. I'm disregarding that other cable for now. And I'm gonna tie it on there smooth. Pull that electrical tape tight. It's got stretch to it. Say not more than 2 laps. At any point on the cable, I'm going to pinch that in. There's a bit of a head right there. I don't want that to hang up. I'm going to take my needle nose. I'm just going to pinch that down. Pinch that head down there. Make sure it's smooth. I'm not worried at this point about damaging any of this wire because I'm actually going to cut it off at the end. There it is. Let's see what we can get. Some of y'all aren't going to understand. This is for demonstration purposes. All right. There's a staple here. Get that out of the way. utilizing my large flathead and prying against the framing. It's now loose. Come on, let's go. Whoo! There it is. Bada bing, bada boom. All right, now what do we do with it? It's not in the right location. Pull a little extra here. Watch this. Watch this. Cut that off. Ooh. Ooh, gotta get me some. There it is. I'm gonna feed this extra over here. Got plenty. Plenty. There. I'm gonna feed. There it is. I was reaching back in there, fishing grabbing that wire that we fished across the ceiling. That's right. I'm gonna bend this one over here so I don't lose it. I'm gonna feed some more conductor length into the hole. Pull it out. I mean, this is where you make your money right here. A little bit of fancy pants magic. Get my needle nose pliers out of there before I forget them. And what I did was I used those needle nose to give me extra length because I'm working through such a small hole. And now I've got my wire. Reposition my ladder. All right, we're gonna spend a minute. We're gonna demystify what's going on here. I don't want it to be intimidating. You can do this. You can do this. There's my wire. Feed a little bit more in there. It's not there. There it is. Come on. Oh, just need it to wiggle and jolt and feed across there. But that angle's too much. All right. So what's going on here? We've got this wire that we just fished across the ceiling to demonstrate that it really can be difficult. The wire comes in here. I'm going to go ahead and cut that. There's two distinct ends at this point. And it relays to this last hole. Now we're not quite here to our destination. I'm going to reach in there, I'm going to grab it, pull it over, and really, in most simplistic fashion, what we've got going on here is we're just relaying from one hole to the next. My switch leg from the switch is going to come into number 1. From number 1, I relay to number 2. From 2 to 3. From 3 to 4. From 4 to 5. And from 5 to 6. I've gone right around the horn. And everything's going to get power. Last thing to do here before we start wiring the lights is to get rid of this old wire. That's my old switch leg. I'm going to identify it and cut as much of it out as I can get to without ripping down the ceiling. And I'm going to make sure that it never gets energized again. All right, so we've located our wire. Check it out. And we are going to be able to reuse that switch leg so we don't leave any garbage lingering in the wall. All right, so at this point, Chris, the homeowner, is pulling his wire out. Getting hands-on here. Oh, there's a staple. There's a fight. Maybe it's just rounding the hole. There it is. Beautiful, Chris. Beautiful. Well done. Is it that one? Yeah. There it is. Get it out of here. You're gonna be replacing this header, right?
Yeah.
Getting some more structural stability in there. And this wire is in good shape. We don't have any damage along its length, and it's long enough. So we're gonna reuse it from the switch location up and through, clearing the header to the first can light. So we've pulled the wire through the ceiling. We have all 6 downlight locations pulled to. We've pulled out our switch leg. And now I'm using my non-contact voltage detector. This is like tool number 1 to keep you safe. I highly recommend it. Link in the description. You just touch it to the wire, and if it doesn't turn red, it's off. What I'm going to do is I'm going to take my switch leg. The circuit's live, mind you. There's power in this box. Some of you are already freaking out. Freaking out. There's power in the box. Know your limitations. You stop respecting it, you will get bit. And I'm going to peel back that hot conductor. I do know that's my hot conductor. White could be hot. You gotta know what's going on. But in this case, it's definitely black, and I'm capping it. So now if somebody throws that switch, no one's getting injured. So that's safe. I'm gonna mount my switch on the inside of the wall. Now watch what's going on here. I'm matching what's existing in the space. So I'm 48 inch from concrete to the bottom of my box. I'm gonna actually mark this on both sides of the wall because I'm open on the back side. Anytime I can use a nail-on box and get a little bit more strength in the mounting, I'm gonna do it. Watch this nail-on box here. I'm going to do one thing. It's meant to be nailed on to this side of framing, so the nails are angled. But what I'm gonna do is I'm gonna reverse it. I'm gonna push it through to the face of drywall after cutting my hole, and I'm gonna nail it on. So, pro tip, I'm gonna reverse my nails too so that they're angling to give my hammer the right approach, space to swing. There it is. So hold my box up. Got this nail right here. It's coming through. I'm gonna clench it, get it out of my way. Hold my box up flush to the stud with the bottom at 48. Trace it. There it is. There it is. My Klein keyhole saw. And now I want to be careful. I am actually going to cut it from the backside here, but if I forcibly send this saw through, I risk tear out on the other side, and it's pretty right now, so I don't want to destroy it. Ooh, it's got some bounce and flux. Nice and easy. Nice and easy. Saw action, not jam action. Beautiful, beautiful. Here goes, here it goes. Oh, good clean fit. All right, I want my nails to grab, so I'm actually gonna recess it just a bit, which will work out fine with my switch. So we're feeling around to the face, making sure we get a good fit. I'm turning my hammer sideways on purpose, so I've got more room to swing. Looks kind of clunky, but I'm gonna have a nice, tight box. Whew. All right, next we're gonna run our switch leg, our reused wire, and the only reason we're reusing it because it's in good shape. It's got good insulation, it's got a full-size ground, there's nothing that's deficient about this. And note, this is 12 gauge, even though it's white, it's just a little bit older before that color coding went into effect. Usually 12 is gonna be yellow. So this is my king stud. Homeowner's replacing that header, but this king stud stays. So I'm clear to drill here. I've got no obstructions that I'm gonna hit up there. And I wanna make sure I'm in the center, front to back of that stud. There are codes about that. I don't wanna be just tucked right in the middle. Beautiful. I'm going to fire cock that hole once the project is over and prevent the spread of flame. All right. Poke it right up in there. There it is. All right, let's fish it to the hole now. Feed our wire up through the hole. I'm going to keep all the wire I need on this end to terminate in my box and provide a nice little service loop there. And take my extra wire here on my switch leg, and I'm going to shove it right across the ceiling to my light. Nothing difficult about it. Before I secure the wire, I want to finish pulling it from point A to point B. Sure enough, there it is. There it is. Good to go. I like it. I like it. Time to make up our lights.
Rolling.
Oh. All right, now we're starting at the first junction. No particular order here. We're going to make up all the lights around the room. If you've got more than 2 wires or more wires than will fit in a manufacturer compliant fashion in your junction box, what you want to do is add an auxiliary junction box with a cover. All wiring connections have to be contained. That's real important. And then check this one out. It's so handy. It's got built-in wire connectors. That junction box, every junction box, has to remain permanently accessible. Every single wiring junction. The fact that these lights pull back out of the ceiling without damaging the building surface, that's key code language. You can slip that junction box after making it up to your wires up inside the ceiling as long as you have enough length to be able to pull it back out. Now, I don't really recommend that because no one's gonna know it's there. So if there's a failure on the wiring connections in this box, it's gonna be difficult to diagnose and troubleshoot at a later date. But if you have to, that's what you can do. All right, I've got a small junction box, so I'm planning 6 inches of strip length. That's all I want, that's all I need. I don't want to have to stuff any more 12 gauge wire inside of that box. Watch out for that open utility blade. There are various types of Romex strippers that are going to be a little bit more friendly than that open blade. All right, here's an alternative to stripping your Romex. It's going to help keep you safe from that utility knife blade. I'm using the 12-2 strip gauge. I'm going to go up 6 inches. I pinch and pull, and there I've got a good clean strip. It's beautiful. Beautiful. That's going to make it real easy to terminate this. I'm not using the provided wire nuts. I'm going to use a larger size because these are not suitable for connection with 2 12-gauge conductors and the 14-gauge conductors that come on the inside of this box. Small flathead screwdriver. Pop out the knockout. Just back and oh! This box is real flimsy. Back and forth. Nice and easy. Don't break anything. All right, so now I'm going to tighten down the connector. I use the phrase all the time, but tool tight. Make it tool tight. Grab my mini Knipex linemans. I'm going to snug it down. There it is. Slide these in. This is the junction box that came with my LED downlights. Want a minimum of 1/4 inch of outer jacket inside my box. I'm going to tighten down the clamp just enough to where I don't have any wire slippage. No death gripping. There it is, there it is. All right, turn and face, turn and face. Here it is, and now it's just a simple color to color equation. See that green and yellow conductor? That's my grounding conductor. So I'm going to strip my outer jackets. These are 12 gauge, so I'm going to use my 12 gauge strip hole. Peel back 3/4 of an inch. Beautiful, beautiful. Oh, a little bit more. And then I'm going to match up my colors, and I'm going to start with my solid conductors first. In this case, my solid grounding conductors. I'm going to twist them to the right, give them a nice pre-twist. If one's longer than the other, I'm going to cut off that excess. I just want them to line up. I want the wire nut to grab both conductors beautifully, beautifully. Here are my wire nuts. I'm using tans. Perfect. And that's the #1 job of an electrician right there, to make good wiring connections. High quality. I want these to be so tight, so right, so nicely, beautifully pre-twisted, patiently pre-twisted, that even if you didn't have a wire nut, you'd have a good wiring connection. Of course, you're going to use a wire nut. All right, color to color. I'm doing it just being thoughtful about how the wire lays in there, so it's neat and tidy, so that I can easily add something, press them all back into the box. Now look at that, there's like a less than 1/4 of an inch. So I'm gonna strip back a little bit more. Oh. Whoop. I'm gonna take those conductor individual strands, twist them to the right, add them. So I've got all my grounds together. This is just a simple color to color equation. I've got it twisted right in there. Now if anything's going to come loose here, it's going to be my stranded conductor. It's the one that might actually get pushed out of the equation by my wire nut, especially if I was using an undersized wire nut and things are real tight. I'm going to pull on that stranded conductor and do a tug test. It should not come out. You can pull pretty hard. Next set of conductors, same thing. It's too short. I want more connection. I want more connection there. I'm going to strip back black and white. I'm going to give them a nice pre-twist to the right. Seated in there, everything just so beautiful. Lots of connection, conductivity. They're all the same length. There it is, there it is. Let it grab that stranded conductor. You'll feel it pulling and twisting into the joint. Give it a tug test. Love it. There it is, there it is. I'm real particular on this one. This is my hot conductor. I'm gonna make sure every little strand is in that joint. I've seen it before where one little strand came out, just was pushed out of place and was up against the metal of the J-box. Turn that switch on and pop. Nice electrical arc, tripped breaker, troubleshoot and diagnose, time wasted. Tug test. Ooh. I don't like it. I've got a little wiggle. Back it off. See what's going on here. Got a little wiggle. Yeah, see, it's just working its way out of the joint. Let's do it again. Look at that fuzzy monster. Into the joint. Work it into the joint. Oh, there it is. There it is. You can feel it pull and grab. Pull and grab. Tug test. Now it's not going anywhere. This electrical joint will last 150 years worry-free.
Hold it for just a second.
All right, so now we're going to tuck it all into the box. Jam and cram are bad words. All our wiring connections are sound. We're folding them over gently, tucking them in there. Look at that. All that's just going to lay and fit beautifully. If I had 8, 10, 12 inches of wire in here, way too much. Way too much. I'm going to fold that over. I'm going to watch. I'm on the lookout for sharp edges, pinched wire. None of that. Snap. Good, 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 good. Nice and tight. I'm going to go ahead and take my whip here. It is a polarized connection. It'll only fit one way. Be nice and gentle. Those pins are real small. Just pressed it in there, and then it twists on. Righty-tighty. There it is. You throw that switch, this baby's going to light right up. What I might recommend to you is go ahead and get all these wired up. Leave them hanging out of the ceiling if you've got any doubt. energize the system, turn on the switch, and just make sure they all light up. If you've got a runt right out of the litter and these things aren't good, guess what? Just twist it off and replace it before you go through the hassle of tucking all this into the ceiling. Take our J-box. Again, I'm going to fold those wires up there. One of the reasons I left extra is because I'm going to have to push and then push them one way or the other to get them out of my way. And I want to have that latitude up there so there's plenty to work with. If I left 2 or 3, 4 feet, that's too much. Now I've just got a big rat's nest sitting in the ceiling. Woo! Cover's popping off as this wire flexes up in there. Ooh, I really don't like that. Really don't like that. That cover doesn't want to stay. It's popping right off. You know what I'm going to do? Zip tie and electrical tape. I don't want to put any screws into this box. I don't want those sharp points damaging my wire. I'm going to take 3 wraps of electrical tape, stretch it tight. I'm going to keep my cover closed. I feel like that's a design deficiency of this particular product. I don't want to rely on my electrical tape for an electrical connection, but for some mild, enduring mechanical strength. If it's good quality tape, I'm okay with that. If it's cheap tape, it's going to dry rot. It's going to dry out and it's going to lose all elasticity, pliability, stickiness. All right, there it is. There it is. Get those spring clips up there. All right, I'm going to clean off that face. As soon as that light turns on, any dust that's left on the lens, you'll see it. So you may notice we lost one of the wires out of this hole. It got jiggled out of the way. Don't ever lose your fish. We just spent 25 minutes getting it back. So we fished it out of this hole. We're sending it back to the other hole. There it is. Come on, come on, come on. Don't ever lose your fish. Don't ever. Fold them over, protect them. Talking and working at the same time. There it is. There it is. All right, on the back side of the wall, I've popped my knockout out of the box, slipping in my switch leg, my hot feed. I don't want to get them mixed up, so I've got it labeled, a little flag of red tape there. All right, there it is, plenty of wire on both. I'm gonna staple it on the back side here. In this case, within 8 inches of the penetration, so get my wire right where I want it. Leave a little service loop. I like that, enough to work with. Accelerate, Jeremy, accelerate. All right, no railroad spikes here, just nice, gentle, soft touch. All right, beautiful. I'm gonna start with my grounds. I'm gonna go to my neutrals. There's only one ground terminal on my switch, so I'm using a crimp sleeve here to combine my grounds. There must be a mechanical connection. If you just twist your grounds together and you don't use some kind of green wire nut or a crimp sleeve, then I would argue we haven't satisfied the code. So because I've got one ground terminal on my switch, I've made a secure crimp. I'm going to crimp it again. It looks a little bit funky. There it is. Love it. Got to keep those grounds nice and tight and right. I'm going to bend that shepherd's hook. Boom. Moving on to my neutrals. These are going together under a wire net. So, same thing. Match the ends. Twist to the right. Now, one point of caution. The white conductor at a switch is not always a neutral. You do have to know if it's a neutral, or it could be utilized as a switch leg or return. So be mindful of the purpose and use of each conductor. If a white is being utilized as something other than a neutral, then it does need to be relabeled with a little flag of black tape or some kind of permanent marking, such as Sharpie or paint. All right, I see a number 2 Phillips. It's just so sloppy in this terminal screw that I'm gonna use a number 1 Robertson screwdriver, which is beautiful. Less force required, no fuss, no muss. There it is. Grab that tip, bend the shepherd's hook. Real important that you bend, wrap it around the screw clockwise. Hear me talking about that all the time. It's a little sloppy. Clockwise, clockwise, so it works into the terminal. I don't want any exposed insulation underneath my terminal screw. I want a good clean connection. I'm going to keep this little flag of tape for identification purposes in case I need to bring another wire into this box at some point. I know the difference at a glance between my hot, which is this guy, he's my power feed into the box, and my switch leg, which is my feed to the light. Let's straighten it up just a little bit. Clockwise, nice gentle wrap. I'm actually pulling on the switch to help that wire seat in there. Righty-tighty, don't death grip it. Man, if you've got a strong pair of hands, you'll actually peel that switch apart. It can actually separate and fall apart in your hands if you death grip that. So I've got all the connections made, and I'm gonna give it just a nice little bend. I'm gonna tuck it all in there. I don't want my ground wire to be in contact with my hot terminals because that's recipe for a dead short. Again, that number 1 square drive, a Robertson. Snug it up to the face of drywall. Don't over tighten. There's not a lot of stress on this switch. It doesn't have to be death gripped. Just gently snugged into place. Make sure it's true and vertical for a good, pretty fit and finish. We're gonna flip on power and give it a test. Before we throw the switch here, I wanna illuminate a couple things. Price tag on this project, between $150 and $200 a light is a reasonable place to land. As a homeowner, you're $900 to $1,200 into the project. As a business owner, you're gonna have 4 to 5 hours in the performance of the job, but you've gotta capture that front-end estimate, the material acquisition time frame, your setup, your cleanup, and your homeowner engagement. You're gonna have 7 to 8 hours in a 4 to 5 hour project because of the peripherals. So don't forget that. 3, 2, 1, boom! Hey, subscribe to Electric Pro Academy for real skills to make real money, and click here for our next video on lighting repairs and upgrades, full of pro tips, codes to help keep you safe and move your project forward.